Hi, I'm Haoyu from Microsoft Research. Today, let me introduce our paper, NeuralFormatting for Spreadsheet Tables. Spreadsheet tables are popular and widely used for data presentation and management. Different from database tables, spreadsheet tables by themselves provide effective visualization for data presentation. As you can see in these examples, Excel tables have various structures and appearances to organize and present data. And formats, such as borders, colors, alignments, and fonts, effectively helps with structuring data layouts. For example, the rich formats on the table in Figure B not only helps to shape the complex hierarchies in the top and left headers, but also helps to scope data groups. On the contrary, it's not intuitive to understand the raw data in Figure A. Hence, table formatting is an important task in the spreadsheet domain. However, manual formatting is time-consuming, especially for professional and complex tables in finance and government domains. We identified several case scenarios for automatic table formatting and built our technologies into a demo. Let's see our demo video first.
Tables are frequently used to organize and present data in most kinds of office applications, including Word, Excel, PowerPoint, Outlook, OneNote, etc. And table formats such as borderlines, colors, fonts, and alignments are critical to effectively presenting data relationships and highlights. But quickly and effectively formatting tables is a challenge for users, especially for complex tables. Lots of manual operations are needed, and the experiences of different office applications vary from one to another. Here, we present Table Format Painter, a unified intelligent experience across office applications for table style transfer and recommendation, empowered by our techniques for table understanding regarding structure and semantics. It would potentially help grow office marketplace ecosystem by encouraging table style designers via promoting their designs to best matching users in an intelligent and data secure way. Let's have a quick demo. Quite often you have such kind of a table and you want to add effective formats. With one click, Table Format Painter can recommend various formatting styles that highlight the structure and important relationships in your data. The ranking criteria is based on the similarity of table structures and table semantics. As you can see, this is a financial table. The recommendations are modern and expressive. If you created a table of scientific experiment report, the recommendations will be very different, and they tend to be clean and artless. This is a table shows NBA statistics of Magic Johnson. The recommended styles are colorful and lively with sharp contrast. In addition, there are also other scenarios. Imagine you want to reuse the style of a well-designed table from your colleague or a template in your company. You can extract the style from a reference table and apply it to your target table. Since Table Painter is smart on matching different table structures, you are not restricted to find a reference table with the same table structure. To be emphasized that, Table Painter supports seamless style transfer from one office application to another. Furthermore, for official documents in companies, you often need to keep the consistency of formatting styles in the same documents, especially when applying an official theme of style that reflects organizational culture. Within several clicks, all tables on this document are painted consistently. Moreover, Table Format Painter supports a unified experience across Office. All the functionalities we showed in Excel are also available in PowerPoint. This table contains sports data of different cricket teams. And it leads to recommended styles that are colorful and lively with font bold and sharp contrast. To conclude, Table Format Painter supports scenarios including recommending styles for a table to best reflect its structure and data relationships, transferring the style of a reference table to a target table adaptively, making multiple tables in the same document with a consistent style, and unifying the formatting experience across Office applications. There are two key challenges in intelligent table formatting. One is understanding table structure and semantics. The other is learning how table formatting is related to the underlying table structure and semantics. Based on our long-term research on spreadsheet intelligence, we have developed the enabling techniques including automatic understanding of various table structures and data semantics, encoding of different table formatting styles regarding table structures and semantics, according to structure and semantic of a given table, recommending styles from a blueprint library or marketplace of high-quality table style designs, decoding and adaptively applying a reference style to a table. Thank you.
As shown in this video, there are different techniques behind our demo. Today, I will mainly introduce a deep learning-based approach for the scenario of automatic formatting generation. We wonder, is there any approach that can automatically generate appropriate formats, such as borders, alignments, and fonts, for this table? Obviously, there are challenges. We summarize three main challenges of auto-formatting. First, table structures and data layouts are often complex. Second, there exist various formatting styles in real-world tables, and makes it challenging to summarize various implicit formatting styles. Third, there is no existing metric to evaluate the quality of table formatting, while metrics are necessary for guiding both rule-based methods and data-driven models. However, there are also opportunities. First, large amounts of well-formatted tables are available on the web with various structures and formatting styles. This motivates an end-to-end approach to learn automatic formatting directly from high-quality corpus. To understand the complex table structures, related work such as table sense shows that convolutional neural networks are promising to capture spatial correlations between cells. Although there lacks a loss function or an objective to score the overall quality of formats, the loss can also be learned by GANs with a generator that makes the output indistinguishable from reality. Furthermore, conditional GANs are proposed to learn the probabilistic mapping from one domain to another domain in conditional settings, and have been successful in various computer vision tasks. This motivates us to learn a one-to-many mapping from table data to table formatting with the CGAN architecture. We provide the first formulation of the table formatting problem. In addition, we propose ways to evaluate the generated table formatting, including subjective evaluation with user perception study and objective evaluation with quantitative methods. We propose a novel method, CellGAN, to learn table format generation with convolutional neural networks in a generative adversarial way. CellGAN achieves superior performance in format generation over all comparison methods, according to both quantitative metrics and human studies. Based on the characteristics of spreadsheet data and formats, we devise a novel row and column-wise polling layer and a local refinement network. Among different format types, borders are one of the most effective and widely used formats to visualize table structures, especially the hierarchical headers and data groups. And alignments are also commonly used to provide neat and clean data presentation. Hence, in this paper, we select border and alignment as two formats to demonstrate the validity of our method. This is the architecture of CellGAN to map table data to formats. The generator learns to generate formats based on data, and the local refinement net is appended to enhance formats with better local consistency. The discriminators learn to distinguish generated formats from real formats. The cross-domain application is never straightforward. First, spreadsheet data has an obvious characteristic. Data are usually arranged row by row or column by column for easy lookup and query. Consequently, table formats also have such row and column level patterns. To capture these patterns in a more effective way, we propose a row and column-wise polling module. By using it, the subsequent convolutional layers can directly integrate both row and column level features, regardless of the kernel sizes used for convolution. Second, viewers are sensitive to the local patterns in table formats, especially in important table regions like hierarchical headers. In order to prevent undesirable local artifacts, we'll need to enforce stronger local consistency of the generated formats. First, to encourage continuous formats in row and column directions, we incorporate a novel discontinuity loss. Moreover, we employ a data augmentation strategy that randomly adds some incorrect local formatting patterns to the input and encourage this network to eliminate them by training with an additional loss for denoising. The overall loss function contains two parts: the adversary loss of the CDN and the losses of the local refinement network. So the key purpose of table formatting is to help users to better understand table structure and data correspondence. So we conduct a perceptual study with 16 Excel data professionals. As shown in this figure, both borders and alignments generated by CellGAN achieved higher scores than those produced by alternative approaches. To the best of our knowledge, there are no existing quantitative metrics for table formatting. First, we propose the table level accuracy as a global metric that describes the proportion of exact matchings between tables with generated formats and real-world tables. Results show remarkable performance gains of CellGAN. TLA is quite a strict metric. We then define the local patch metric, LPM, that consider patches from real world as natural patches, and statistically measure the naturalness of generated formats. Results show that the local refinement network achieves about 4% to 12% gains in the local patch metric. CellGAN can also learn meaningful controllable variables. In these experiments, one can generate different border lines through specifying different border densities. When border density is specified to 0.3, few border lines are generated, and 0.6, more border lines, 0.9, even more, showing the ability of CellGAN to navigate intrinsic styles. There are also bad cases. This case shows inappropriate border lines in the red circle. It seems that CellGAN is fooled by the black region in the bottom right and tries to generate a bottom border line for this region. This case shows that the generated border lines are inconsistent among peer data groups. A main cause for this bad case is that the top header of the table is hierarchical and complex with 9 rows. As the last cases show, table structure understanding is very important to formatting generation. In the future, we plan to investigate fine-grained table structures to enable high-quality formatting generation for various complex tables. And since there are various formatting styles in real world, we also want to explore recommending various formatting styles with appropriate ranking. Thank you. Any questions?